इंट्रोडक्शन टू साइंस. व्हाट इज साइंस? कि साइंस क्या है? साइंस इज व्हाट साइंटिस्ट डू. साइंस इज ट्राइंग टू एक्सप्लेन द वर्ल्ड अराउंड अस. साइंस इज अ वे ऑफ थिंकिंग. Science is a system of knowledge based on facts or principles. Book tells about social science. We prefer social studies. Branches of science. There are three main branches. 1. Biological science. 2. Physical science. 3. Earth science. Biological science is the science of living things, which is zoology, botany, ecology. Physical science is the science of matter and energy, which is physics, chemistry. Earth science, the system of Earth, geology, meteorology, astronomy. Branches of sciences. There are many more branches to biological and earth sciences. The three categories overlap: biochemistry, astrobiology, geophysics. Science and technology. Pure science, search for scientific knowledge. Technology, application of science. Two are interrelated. Technology develops new tools for investigating nature. New science lead to new applications. Scientific theory, a reasoned explanation tested by many observations and experiments, tells why things are. Three things: must explain clearly and simply, must be repeatable, must be able to make predictions. Theories can be changed or modified by new evidences. Scientific laws describe what happens. Quantitative, use numbers and equations to describe. Often equations are part of the law. Mathematics is universal language. Law versus theory. Law describe how, theory explain why. Law summarizes the observations, while theory agrees with observations. Law usually an equation, while theory predicts new discoveries. Observations. Qualitative, describe with words: hot, red, large. Quantitative, describe with numbers: minus 100 degree, 10 meters, 3.46 grams. Scientists prefer quantitative, easy to agree upon, no personal bias. Models, a representation of some object or event made to better understand it, often used if real thing is too big, small, or complex. Come in a variety of forms: physical models, diagrams, computer models. The scientific method, a way of thinking about and solving problems. It is a logical method. You do it all the time. The scientific method, start with observation, can be anything. Question, what do you want to know? Gather data, what is already known. Form hypothesis, a possible explanation. Design experiment to test hypothesis. This is the hard part. Scientific method, experiments generate more observations, allow us to draw a conclusion about hypothesis, support the hypothesis or not. If not, modify hypothesis. The scientific method model. First, observe. Second, formulate a question. Third, collect data. Fourth, form hypothesis. 5. Experiment test hypothesis. 6. Observation, observation, observation. And the last and the seventh stage is draw conclusion. This is the scientific method model. Observation, formulate a question, collect data, form hypothesis, experiment, test hypothesis, observation, 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 and draw conclusion. If the hypothesis is not good, modify or form new hypothesis. Experiment, test hypothesis, observation, 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 and draw conclusion. The scientific method does not always work this way, but gives a way of guiding our thinking. Hard part is testing only one variable at a time, changing only one thing at a time. If you change more than one, you don't know which one is the cause. Measurement. A number without a unit is meaningless. It is for long. For what? Scientists use the metric system or SL for System International Unit. Make sure makes sure make shoring makes sharing data easier. So scientists use basically the SL for SI unit for System International Unit. They used to get the correct measurement, makes sharing data easier. Metric system. Measurements have two parts, base unit and prefix. Prefixes multiply or divide the base unit by multiplies 10. Prefixes are the same for all units. Base units, quantity unit abbreviation, length meter m, mass gram g, temperature Kelvin K, electric current ampere A, amount of substance mole mol, luminous intensity candela CD. Prefixes, prefix symbol meaning as a number, kilo K thousand 1000, mega m million, 10 lakh 10 lakh, giga g billion, deci d tenth 0.1, centi c hundredth 0.01, milli m thousandth 0.001, micro u millionth 0.000001. Tables. Organizing data into groups, putting those groups into rows and columns, give us an easy way to compare data. Graphs. Give a visual representation of data, summarizes data, two types of variables, independent variable, the thing you have control over, dependent variable, the thing that you don't have control over. Three types of graphs, line, bar, and circle. Circle graphs, often called a pie chart, divide into parts, easy to compare to whole amount, use several to show changes over time. For example, building, transportation, industrial, buildings 33%, transportation 25%, and industrial 42%. In this circle graph, bar graph, white columns use things like weight, height, and length. Compare quantities. Production of energy per gram. Fats, proteins, carbohydrates. Line graph. Line graphs compare sets of data, shows changes and patterns over time. New York, San Diego, Salina Cruz. Salina Cruz. Graph include a title, labeled axis, a consistent scale. Metric conversions. Changing the unit does not change size of the measurement. If the unit gets bigger, the number gets smaller. If the unit gets smaller, the number gets bigger. Math with multiples of 10. We will cancel out units to make sure we set the problem up right. Metric conversions. A common race is the 5K, which is 5 kilometer. How many meter is this? Give unit km, unit wanted m. The unit gets bigger, so the number must be get bigger. 1000 meter is equal to 1 kilometer. Metric conversion, distance in meter is equal to 5 kilometer, multiply 1000 m meter over 1 kilometer. So we cut kilometer with kilometer, 5 with 1, 5, 1, 5, and multiply with 1000. 5000 meter is the distance of 5 kilometer in meters. Metric conversions. The recommended daily requirement of vitamin C is 500 milligram. How many grams is this? So we cut mg with mg, 500 is left. So we cut two zeros with 5 zeros, and the answer mass in gram is equal to 0.5 m. Measuring length. Use a ruler. Line up from 0 not the end of the ruler. Small divisions are millimeters. Volume. Liter common unit. 1 liter is about 1 over 4 of a gallon. A quart. 1 ml is about 20 drops of water or 1 sugar cube. Measuring volume. Use a graduated cylinder. The water will curve in the cylinder. Hold it level with your eye. Read the bottom of the curve. Measures in millimeter, ml. Mass. Weight in a force is the amount of matter. 1 gram is defined as the mass of 1 cubic meter of water at 4 degrees centigrade. 1 kilogram is equal to 1 liter of water. 1 kg is equal to 2.5 pound. 1 gram is equal to 1 paper clip. 1 mg is equal to 10 grains of salt or 2 drops of water. Measuring mass. Use a triple beam balance. First balance it at 0. Then put item on. Then move one weight at a time. When balance add up the weights, science education. What is science? Two views of science. Science as a process, science as a product. Process of science. Identifying problems, observing, hypothesizing, analyzing, inferring, extrapolating, synthesizing, evaluating, etc. Product of science. Facts, concepts, generalizations, principle, theories, laws. Nature of science. There is no single set or consequence. There is no single set or sequence of steps in a scientific investigation. Scientific knowledge is a subject to change. Scientific knowledge must be supported by empirical evidence. Scientific knowledge is partially the product of the creative imagination of scientists. Scientific knowledge is not totally objective. It do have some degree of subjectivity. Scientific knowledge is a product of both observation and inference. Dimensions of scientific education. Knowledge. 1. Facts, concepts, theories, laws, and their applications. Historical developments, teaching of Islam, social and economic impact of science and technology. Number two, activities. Using learned knowledge, constructing new information, developing concepts, strengthening skills. Number three, real world context. Science cannot be taught in isolation. Establishment of relationship is essential. Environment, animals and plants and their systems. Society, physical phenomena, motion, magnetism and rain. Earth and space. Goals of science education. Knowledge. 1. Facts, concepts, and conceptual schemes, laws, and principles. Goals of science education. Number 2. Skills. Observing, classifying, measuring, analyzing, making inference, applying, communicating. Again, observing, classifying, measuring, analyzing, making inferences, applying, communicating. Goals of science education. Number 3. Behaviors, attitude, interests, appreciations, values. What to assess? Number 1. Knowledge, fact, comprehension, application, analysis, synthesis, evaluation. What to assess? Continue. Facts, observing and recall of information, knowledge of dates, events, places, knowledge of major ideas, mastery of subject matter, comprehension, understanding information, grasp meaning, translate knowledge into new context, interpret fact, compare, contrast, order, group, infer causes. What to assess? Application, use information, use methods, concept, theories in new situations, solve problems using required skills or knowledge. Analysis, seeing patterns, organization of parts, recognition of hidden meanings, identification of components. What to assess? Continue. Synthesis, use old to create new ones, generalize from given facts, relate knowledge from several areas, predict, draw conclusions. Evaluation, compare and discriminate between ideas, assess value of theories, presentation, make choice make choices based on reasoned argument, verify value of evidence, recognize subjectivity. Questions cues. Number 1. Knowledge, list, define, tell, describe, identify, show, label, collect, examine, tabulate, quote, name, who, when, where, etc. Next is comprehension. Summarize, describe, interpret, contrast, predict, associate, distinguish, estimate, differentiate, discuss, extend. Next is application. Apply, demonstrate, calculate, complete, illustrate, show, solve, examine, modify, relate. Analysis, analyze, separate, order, explain, connect, classify, arrange, divide, compare, select, explain, infer. Synthesis, combine, integrate, modify, rearrange, substitute, plan, create, design, invent, what if, compose, formulate, prepare, generalize, rewrite. Evaluation, assess, decide, rank, grade, test, measure, recommended, select, judge, explain, discriminate, support, conclude, compare, summarize. Again, revise the knowledge. Number one. Number two, comprehension. Number three, application. Number four, analysis. Number five, synthesis. Number six, evaluation.